Right? If you got stuck, we talked about, you could always just plug in some different x values and try to get y values and plot some points. And that wouldn't be so bad with exponents because you're more familiar with exponents. Not always perfect. Negative exponents are difficult for us sometimes and stuff like that. But we're more familiar with exponents. So the next thing we're going to do is we're going to start graphing log functions. But if we're supposed to graph a log function, which means we're going to have to build a parent function. So we're going to have to know, oh, when I plug in this, I get this. And if I get stuck, I want to be able to plug in some points. Then I have to know how to calculate a logarithm. Okay? So first, remember, I like to remember like one basic fact of how things look. So 2 to the third power is equal to what? 8. Okay. All right. We can't do exponents. We can't do logs. Okay. So 2 to the third power is equal to 8. If I was going to write this in log form, this is what I would write it as. Log base 2 of 8, is 3. Okay. So a couple of things to notice to help put your mind in the right thinking mode when you're dealing with logarithms. The base of the exponential function is the base of the log function. Okay. The difference is in an exponential function, I give you the base and I give you the exponent, and I ask you what is the total value of that power, and that's how you guys came up with 8. The logarithm is like asking that question in a different way. I'm saying if the base is 2 and you know the answer is 8, what is the exponent? And so you're coming up with what exponent is that would be on 2 to produce 8. So that's where we're getting 3. So a logarithm is like a question. Which exponent do you put on this base to get this result? Okay, in other words, what exponent do I put on base 2 to get 8 as a result? And then the answer is 3. Okay. All right, so first question. Log base 3 of 9. So it's really asking you, what exponent would you put on 3 to obtain 9? So 3 to the third power is 9? 2. It's okay. We want to do multiplications. So my answer is 2. So these things end up being calculating and having a single value, just like if we calculate a power and it has a single value. Okay? If I want to check my answer, I check. If I take the base and I put your exponent that you selected on it, do I really get what was inside the logarithm? Yes. Okay. All right, so log base 5 of 125. Caitlin? 2. 3 squared equals 9 is just me rewriting it and checking that it makes sense. Okay, Sean? It'd be 5. Now, 5 times 5... No. 5 times 5 is 25. 5 to the 5th power would be a lot of 5. Let's see. So that's like, yeah, to the 3rd power. Okay. So 3 is the answer for that one. Okay, so they get a little bit trickier. All right, when we start, trippier. As we start getting into things with negatives, fractions, zeros, where our exponents got a little trickier, the logarithms get a little trickier too. Now, if you're struggling with this, you can go through and you can solve it like an exponent problem, like we did on exponent review day. You can literally rewrite this as an equation and say, they are asking me 5 to what power equals 125. As long as you can get what question they're asking you, then you could go about solving it. And then remember, to solve these problems, we just wanted to rewrite each side with the same base. So if you rewrote 125 as 5 to the 3rd, you would see that the value of x should be 3. Okay, but don't write x equals 3. There was no x in this to begin with. Just say 3 is the answer. Okay. All right, so log base 1/3 of 27. Any ideas? Ariana? It is -3. Very good. Okay. Okay, if we didn't see, so one reason to know that a negative is incorporated is, look, your base is a fraction, But if you just took 1/3, 1 on top, 3 on bottom, and kept raising it to powers, you'd keep getting a 1 on top, and then you'd keep getting powers of 3 in the denominator, so you'd keep getting a fraction. The only way to get that fraction to turn into 27 as a whole number is to flip it over so that the 3 is on the top and the 1 is on the bottom. So that's how I would mentally know that, like, there's probably a negative power involved. And then I know that 3 to the 3rd power would give me 27. If that whole mental math thing, you're not good enough with exponent rules to do that, then you go through rewriting it. Okay, this problem is asking me 1/3 to what power would equal 27. And then I want to rewrite each of these with the same base. So 1/3 is like 3 to the negative 1 power, and then it has the x exponent. 27 is like 3 to the 3rd power, and then I can set the exponents equal and see that I should get negative 3. So again, it kind of depends on how familiar you are with your exponent rules. If you've really caught on to how this negative exponent idea works, you might have seen right away that that had to be a negative response. If not, you set it up and you go through the process we went through to try and solve those equations that had different values on each side, make the same base, and figure out what the exponent would be. Okay? All right, what about log base 5 of 1? Jordan? Good. What about like log base 80,000 of 1? 0, okay? Because the only way to get 1 as a result with a different base is to raise that base to the power of 0, because anything to the 0 power equals 1. All right, what about log base 2 of negative 4? So it's saying 2 to what power equals negative 4? So is there any exponent that can turn a positive number into a negative? No. What do negative exponents do? They just like put it in a fraction, but nothing changes the sign of the power, right? So this one's bogus. Okay? There's no solution. Because you got to make sure you know where there's no solution. It's going to be important to us when we graph it. Okay? You know these whole little asymptote things that we've been talking about? And they kind of like cut the graph off, and then the graph hasn't been existing on the exponent ones kind of below it. In the log ones, it's going to turn sideways, and it's going to be like, oh, yeah, you were good up till this point, and then there's like no solution over here. So therefore, no graph over there. Okay? It's going to help us divide up our graph. Okay, what about log base 3 of 0? So 3 to what power produces 0? No solution again. Okay? Because if you try to plug in 0 for the power, what are you going to get? 1. So those are important for us to know, okay, and kind of recognize. So if I want to take a logarithm of a number, I cannot take a logarithm of 0. No matter what I change my base to, there's no way I'm going to get 0. And I can't take logarithm of a negative number. So those values, no matter what the base is, will always be undefined. And the other ones, we're either going to know right away what the exponent should be that answers the logarithm question, or we're going to have to do a little more work, but we can figure it out with our exponent skills that we built up at the beginning of the unit. Okay? Does this kind of refresh your memory about what logs were about? And maybe why we did exponent review also? If we don't know our exponents, can't find our logs. Okay, so why we want to know how exponent and logs are related is because it's going to help us solve for some stuff. So as we're graphing the next things, we're going to find x-intercepts and y-intercepts. And you know, to find the intercepts, you set something equal to 0. So we've only been finding y-intercepts in your exponential function, so let's say you had something like this. I've only been asking you for the y-intercept, so you've been plugging in 0 for x and then finishing your calculation. Fine. If I had asked you for the x-intercept, what would you do? Put y equal to 0. This makes a much more complicated equation to solve, because then we'd have to add 5 to both sides, and we have this. Now, if this said 3 to the x power equals 9, I'd be happy, and I'd be able to answer the question. But it doesn't say that. It says 3 to what power equals 5. Okay, I don't know 3 to what power equals 5. Any idea how we solve a problem like this? Do you guys remember from Algebra 2? You use logarithms, okay? So I haven't asked you for an x-intercept yet because I hadn't reviewed logarithms with you guys, but I'm going to end up asking you x and y intercepts on both exponential and log problems. So we want to remember what the log is, and we want to remember how to solve problems using log and exponent. Okay? So the problems you see right here, I realize don't look like this, okay? Because it works both ways. All of these problems up here are problems we're going to start graphing, because they're all equations with logarithms in them. Okay? But if I wanted to solve these equations for x, I use something similar. So if I wanted to solve an exponent equation that I looked at as kind of unsolvable, I would use logarithms. If I want to solve a log problem, I change it to exponential form. So again, I want to go back to the fact that I always remember one thing here, because this is going to help me with these problems. To solve these problems, I'm going to rewrite them. I'm going to change what they look like. If it doesn't seem solvable the way it's written, rewrite it in the other form. And I'm talking about logs and exponents. So this is a log. If I don't know what I should put for x to get 3 over 2, rewrite it. Okay? When I say rewrite it, in that problem, what is the base? 9 is the base. So 9 is going to become the base in my exponential form also. So this is going to be 9 raised to some power equals something on the other side. Which part of that equation is the exponent? If you have to, refer back. This is why I keep track of one that I know. Here was the log form. Here's the exponent form. Yeah, the answer to the log problem is what's the exponent in this. So here, 3 over 2 should be the exponent. And then what goes on the other side is going to be x. This is more solvable for me now, because now all I have to do is complete this calculation right here. Okay? What is 9 to the 3 over 2 power really telling me to do to 9? What is this 2 in the denominator of the exponent telling me to do to 9? Okay, good. Square root 9. And then raise it to the third power. You could technically do them in any order, but I know the square root of 9, and I want to make it smaller first. So the square root of 9 is going to be 3. Then I'm going to raise 3 to the third power, which is going to give me 27. Okay? All right, so someone new, rewrite the next one for me. Because I don't know log base 6 of what would equal 2. I don't know. Maybe I do know off the top of my head, but if I don't know, I want to rewrite it. So someone tell me how I can rewrite the second problem in exponential form. Okay, 6 is the base. 2 is the exponent. Equals x. So x is 36. Easy. All right, a little more complicated, the last one. All right, someone help me just rewrite it first. Just put everything in the right place, and then we'll talk about the whole solving part of it. Okay? So Ryan says 5 squared. So 5 is the base. 2 is going to be the exponent. And on the other side of the equation, everything that was in the log. So the bummer about this problem, if you want to think about it that way, it just depends on perspective, I guess, is that it's a quadratic. The x is squared, so it's not as simple as solving the other ones. But I still have the tools now to solve this. I'm going to go ahead and get x alone, since there's not another term with x. You could factor. You couldn't factor how it was right now, though, because you can't factor and set equal to 25. You'd have to factor and set equal to 0. And then I'll square root both sides, which is going to give me that x could be equal to or negative 13. Because remember, when you square root both sides, you use plus or minus. Not at that point. So the reason you don't want to change x squared minus 144 to x plus 12 times x minus 12 is that's only helpful when it's equal to 0. And right now it would be equal to 25. You could move the 25 over, and then you'd have x squared minus 169, and you could factor that to x plus 13 times x minus 13 and get the same two solutions I did. But once it's set equal to 0, you can do that. Megan? Yes. Mm-hmm. All right, so I got 13 and negative 13 as my answers, and then I just have to make sure those both work. If we look back at the problem, Notice if you plug them in, you would square them, which would be 169. And when you subtract 144, you would still have a positive. I just want to make sure that none of the answers I got put a negative or a 0 inside the logarithm. Because remember on the slide before when we were calculating logs, if you try to take the log of a negative or you try to take the log of 0, you really have no solution. So I just want to make sure when I am solving, it's okay that this turned out negative. That is still a good solution because if I put it back in the problem, it does not make a negative value inside the logarithm, even though the number itself was negative. So these are both good solutions for that problem. Okay? Are we okay with this whole rewriting thing? It's going to help us a lot, so we got to pay attention to it. All right? Okay. I don't know why Part D is the same as what we did. I don't know why that still exists there. Okay, but we only need to look at Part D and Part E. I don't know what the third thing up there is for. But we're going to run out of time, right? Yeah. Okay. All right, so don't worry about this.